Hello students, in this video I would like to discuss about working of a digital computer. To execute or run a computer program, it must be loaded to memory. So in the previous video we discussed about computer program. Computer program is nothing but a sequence of instruction. To execute this instruction, first that instruction must be loaded to RAM or memory. So if we have a computer program, most of the time we will store the computer program as a file in secondary storage. So to execute that program, we have to load that program from secondary storage to main memory or to RAM. For example, we all are familiar with a software called VLC. So software is nothing but a collection of program. So when we install VLC player, it will be in hard disk. Most probably it will be in C drive of the computer. So when I double click on that VLC icon, that software or the required programs in that software will get loaded to RAM. So next point, the program counter is the register that keeps track of what instruction has to be executed next. So program counter is a register. We already studied about register. It is a memory inside processor. It's a register which has to keep track of what instruction has to be executed next. At the first step, the instruction is fetched from main memory and loaded into instruction register. Here instruction register is another register which is in the processor. So these things will be clear when you study the example. To access data in memory, CPU makes use of two internal registers. So similar to PC and instruction register, we have to study two more registers, MAR and MDR. The memory address register holds the address of a memory location. So that MAR also can hold only address of a memory location. Similarly, program counter is also a register which can store address of a memory location. The memory data register, sometimes known as the memory buffer register, will hold a data value that is being stored to or retrieved from the memory location currently addressed by the memory address register. So I already told you memory address register will contain some address. So suppose I want to read some data from RAM or from memory. So to read some data from memory, I have to specify that address location. That address location will be specified in memory address register. And if I produce a read signal, the data in that particular location will be read. Suppose I want to write some data to a particular memory location. At first, the address location or the address will be stored in MAR register and the data to be written is stored in MDR, and I will produce a write signal. At that time, the content in MDR will be copied to that particular memory location. Immediately the PC is incremented so that it points to next instruction in the program. So this step is actually the continuation of this step. So after the instruction is fetched or the instruction is stored in instruction register, the program counter value will be incremented. Once in IR, the instruction is decoded to determine the actions needed for its execution. So when instruction is stored in instruction register, it will undergo a decode operation. Decoding is the process of splitting instruction into operators and operands. For example, C equal to A plus B is an instruction. Here we have three operands. C, A, B are operands and plus and equal to are operators. We all know what's the purpose of plus operator, to add those two contents or to add those data. Here equal to means some value will be stored in C. So that some value will be assigned to C. So here equal to is considered as a storage operator or assignment operator. The control unit then issues the sequence of control signals that enable execution of the instruction. So after decoding, the control unit will send a signal to processor to execute the instruction. So ALU will perform the required operation. Here we have to perform addition. So ALU will perform that operation. Data needed to be processed by the instructions are either fetched from a register or from RAM through an address register. Here address register specifies this MAR. So the data required to perform the instructions are either stored in RAM or register, and that will be fetched with the help of address register. The result of the instruction is stored to either a register or memory location. So once we perform some instruction, we will get some result. All instruction doesn't produce result. There are instructions which produce results, and such instructions we can store data either in register or memory location. The next instruction of a program will follow the same steps. This will continue until there is no more instruction in the program. So here you have to remember these 4 things: fetch, decode, execute, and store. For every instruction, this fetch, decode, and execution is mandatory. For every instruction, we didn't have that store operation. So fetch, decode, execute is there in every single instruction. So this working of a digital computer will be more clear when we see the example. So here I have a simple example to add 2 numbers. The first thing you have to remember is to execute a program or to execute a sequence of instruction or even to execute a single instruction. The first thing is that instruction must be stored in RAM or in memory. So here I am going to add 2 numbers. So I have written as instruction sequence. So this is only for understanding purpose. This is not an example for any programming language. This is only for understanding purpose. So these are the set of instructions I am going to give to computer. So to execute this instruction, first thing is it has to be loaded to main memory. Sometime I may write these steps in a file and I will store it in a hard disk. So for execution, with the help of some software, I will execute this program. At that time, this program will be loaded to memory. So I already told you, every memory location will have some address. So here I am using some numbers just to denote these are address location. So in address location 1000, I have an instruction called allocate space for A, B, C. Because I need 3 variables or 3 spaces to add numbers. So only 2 spaces required to store those 2 numbers, and the 3rd space is required to store the resultant. So you remember this sequence of instruction or this program is in main memory. The previous slide we discussed 4 steps: fetch, decode, execute, store. So this will happen in a cyclic order. So first thing will be fetch. So here what is the first instruction? Allocate space for A, B, C. So in the previous slide we discussed about 2 registers, program counter register and instruction register. So program counter register contains address of next instruction to be executed. So I am going to execute this instruction. Since I am going to execute, the next instruction going to execute is allocate space for ABC. Its address location is 1000. So the meaning is in 1000 location of RAM, we have one instruction. Next, with the help of this memory operation, with the help of that MAR and MDR register, the instruction in that location will be stored in IR. So instruction in that location is allocate space for ABC. So that fetch operation is completed. This instruction register is actually a part of processor. So this instruction reached the processor. So once this instruction is reached, the program counter value will get incremented. Incremented means it will store the address of next instruction. The address of next instruction is 1002. That's why I told you program counter always contain address of next instruction to be executed. So these things happens during fetch operation. Next is decode. So this instruction will be decoded. This decode happens in control unit. So here I have 3 operands A, B, C. So what is the operation I have to perform? Allocate space. So I have to allocate some space in RAM for A, B and C. So that will be executed by the processor and some space will be allocated in the same RAM. In some other location, some space will be allocated for A, some space will be allocated for B and some space will be allocated for C. So that the execution of that statement is completed. So that execution happened. Nothing to store. I already told you the fourth step is not mandatory. So the next instruction will be fetched. What's the address of next instruction to be fetched? It is 1002. So what's the instruction? Read value of A from keyboard. So that will be stored in instruction register. The next thing happens is the program counter value will be incremented. It will become 1004 because it points to the next instruction to be executed. So read value of A from keyboard. So, and the operation has to be performed is have to get the value from keyboard. That means user have to enter some value in the keyboard, and that value must be stored in A. What is A? A is actually refers to another memory location. So definitely user will enter some value. You just imagine user entered the value 10. So after execution of this statement, the value 10 will be stored in the memory. So that second step is also completed. So next we will look at value in program counter, that is 1004. The instruction is read value for B from keyboard. So that will be stored in instruction register. After that, the program counter value will be incremented and it will be 1006. Then this instruction will be executed. So this control unit will decode it. So this is same instruction what we have seen earlier. So the user will enter some value. You just imagine he entered 15 and that will be stored in this B. This A, B, C are the space we are already allocated by executing the first step. So that step is also completed. The next step will be executed, that is 1006. So the instruction is C equal to A plus B. Next, the program counter value will be incremented. So it becomes 1008 since the next instruction is stored in location 1008. So next the control unit will decode this instruction. So decode means splitting into operands and operators. Here I have two operators equal to and plus, and I have three operands C, A and B. First thing is A plus B will be executed. A and B will be added. That means 10 and 15 will be added. And it will be stored in C. C means this memory location. So here I will get a value 25. So that execution also completed. Here actually there is a store operation because some value for C is stored in memory location. So in 1002, 1004, 1006 we have store operation. So that instruction is also complete execution. It is stored in main memory. So next program counter value is 1008. That instruction will be stored in instruction register. Display value of C in monitor. So it will be executed. The operand here is C. So that C value will be displayed in the output device. C value means this 25 will be displayed in the output device. So we reach the end of the program, or we reach the end of sequence of instruction. That execution of that program is completed. So this is how the digital computer works. This is how the softwares are executed. So here you have to understand the difference between instruction and data. So here I have a program, instruction. The data in which this instruction act upon is actually these three things, 10, 15, 25. So I hope you understood the difference between instruction and data. Instruction means set of instructions. Data means the thing on which the instruction act upon. Okay, next is von Neumann model. Von Neumann proposed his computer architecture design in 1945, which was later known as von Neumann architecture. It consists of a control unit, arithmetic and logic unit, memory registers, and inputs, outputs. Von Neumann architecture is based on the stored program concept, where data and program are stored in same memory. This design is still used in most computers produced today. So von Neumann model is nothing but what we have studied. So von Neumann model contains some control unit, some ALU, some memory registers and inputs and output. And more importantly, it follows stored program concept. Stored program concept means data and program are stored in the same memory. So here program and data are stored in the same memory. So in the real-time example, instead of this instruction, you can consider VLC software, because VLC software contains a set of programs. To execute that VLC software, we have to load that set of programs in the RAM. So it can be considered as the instruction part. And in place of data part, you can consider various files, some MB4 files or some MB3 files, which you use to listen music or to watch some movies. So that movie file can be considered as a data part, or that MB3 music file can be considered as a data part, and the VLC software can be considered as a program part. So both the program and data are stored in same RAM or in same memory. That is called stored program concept or von Neumann model. That's all I want to share in this video. Thank you.